EOQ model, economic order quantity model. As we have discussed, the EOQ model will tell us the optimal order quantity of your store. And usually when we talk about this store, it's probably distribution center or retailer store. And one question I want to ask you guys, why EOQ model, the optimal order quantity model, doesn't fit very well for manufacturing, like factory? Why EOQ doesn't fit very well for manufacturing? My question clear? If you are a retailer store, distribution center, EOQ, you should definitely consider optimal order quantity. When you are a manufacturer, instead, EOQ most likely won't fit very well for your inventory management or order decision. Why? Huh?
You can't get to zero when you gotta deal with the
Production.
production.
Sometimes you can get. One important reason is that what is the most important decision for manufacturing? Is that the ordering? No. What is the most important decision for manufacturing?
Sales.
Sales. Sales is not the decision. Decision is production, right? If you're a manufacturer, the most important decision for you is the production. EOQ can't tell you the production plan. EOQ can only tell you the ordering plan. But if you don't produce anything, you just order and resell it, then EOQ can be a perfect model for your business. Now we'll see a model who can tell the manufacturer, okay, what is your production plan? If you are in the really upstream of the supply chain, manufacturing position, right? So the best mode is widely used in production. In some situations, the capacity to produce a part exceeds its usage, which means, well, given like one day, you can only sell 100 units, but you can produce 500 units. That is very true for most production or manufacturing, right? So, which means you shouldn't continue to produce. You should produce sometime and stop, wait until consume all the inventory, and then reproduce again. In this scenario, manufacturing and the capacity of production is higher than demand, we should consider the EPQ, economic production quantity model. Assumptions are very similar to EOQ model, only one items. We know the annual demand, which means demand forecast is close to perfect. Usage rate is constant, so every day, okay, we ship the same quantity out. It happens continuously for the demand, but production happens periodically. The reason why it's periodically because your production rate is higher than your demand rate. You shouldn't produce it continuously. Also, production rate is constant, lead time is fixed, no quantity discount. If your factory satisfy all of these assumptions or closely satisfy assumptions such as forecast is pretty good, then we can consider to use this economic production quantity model to tell us what is our optimal production plan. Okay? So this graph is much more complex than the EOQ graph. Let's have a quick review on the EOQ graph. Okay? For the EOQ graph, every time we order quantity Q, optimal order quantity, right? By the constant demand, so it's a straight line going down to zero, we have discussed why we can reach zero. Because the lead time is fixed, it's pretty easy for us to figure out the reorder point, and then when we receive the order, the inventory is zero. Then come back to Q0, Q0. That's the EOQ's inventory graph. EPQ, a little bit complex. You spend some time to explain this graph. Okay, there are two lines. One is the solid line, right? And another is the dashed line. Okay, the solid line is the inventory level. So that means from day one, you have increase inventory until I don't know which day, like the end of 30 days, you reach the maximum inventory. IMAX means maximum inventory. It's not the movie theater. I know you guys like IMAX. I also like IMAX, but IMAX is the maximum inventory level here. So you can see here is from day 1, let's say day 3, it's continuous increase in constant rate. We'll discuss why it's happening that way. Well, the dashed line is the production line. Right? QP is the decision variable for us now. It's like Q in the EOQ model. QP is the production quantity. Well, Q itself means your order quantity, like EOQ. But here, QP represents production quantity. So the dashed line up to this level is your decision variable. You will produce up to QP, then you stop production. That's your decision variable. You have to tell me, okay, what is the optimal QP? How many units you want to produce up to? 1,000, you stop. 2,000? 500? Okay, that's the point to stop. What's happened after you stop production? What's happened? In this brown or yellow area, what's happened? After you stop production at the end of day 3, what's happened? This part. What's happened?
What's being used?
Yeah, only sell stuff. You don't produce stuff anymore, right? Then that's the reason inventory level keep going down, because you don't produce. You can't accumulate further inventory. You just consume your on-hand inventory until it's come back to 0. When it's come back to 0, we resume the production again. We begin the second cycle. So that's EPQ. So keep that in mind, is that the solid line represents the inventory level and the dashed line is the production level. Oh, now several questions. First question, I want to ask you guys. This dashed line, right, is increase. It's a straight line. Why is it a straight line?
Linear?
Why is linear? Think about the assumptions we have discussed. Why the production quantity increase straightly?
The production rate is constant.
Very good, Michael. Because the production rate is constant, that means every day we produce 200 units, right? So every day is the same amount. So we don't produce a lot on Monday or less on Tuesday, right? We produce the same amount. So the dashed line is a straight line, it's a linear line, right? No problem. One thing those show here is the demand line, right? We didn't show up here, but demand line, we know the demand rate is constant. Now come back to the solid line, inventory. You can see this line is always below the dashed line, which is the production line. Which, for example, on day 1, maybe we produce 200 units. Our on-hand inventory is 100. Day 2, okay, we produce another 200 units. Now we have 400 units. And our on-hand inventory is 200 units. The question is why we have on-hand inventory accumulated in the first 3 days. Why we have increased on-hand inventory?
Because we don't use up all the inventory we produce?
Yes. Because our production rate is higher than the demand rate, right? That's the important assumption, right? We have. When the production rate is higher than demand rate, that means you produce 200 units. Customer only order 100. That's day 1. How many on-hand inventory you have? 100. Okay. Day 2, you produce another 200 units. Customer order another 100 units. How many on-hand inventory you have at the end of day 2? 200. Right? You do the same thing on day 3. You have 300 on-hand inventory at the end of day 3. Right? And you can't doing that anymore, right? Because you know that this is not rational. Okay, because if you keep produce stuff, you have more and more inventory. So that's a lot of cost. So that's why we stop at some point. Your decision variable, you decide when to stop, right? It really depends on this QP and production quantity. And you stop here. After you stop here, the inventory level won't increasing anymore, right? It becomes the decreasing trend. And the slope of this decreasing line is in fact the demand rate. right? For example, if you have 300 on hand here, every day you consume like 50 units. Day 1, day 2, day 3. So the slope is the demand rate for the second part of this solid line. Clear? Yeah, the consumption rate, right? Until it's reached 0 again, and you come back to the second cycle. So that's the EPQ model. Well, our decision variable is QP to minimize our total cost. Just pay attention here in the example we are doing today. We have to calculate the inventory level. Well, not just QP. Well, we'll talk about this IMAX. Right? Your favorite is IMAX. So EPQ, same idea as EOQ. We want to minimize the total cost. So the total cost function is the holding cost or carrying cost plus the setup cost. Now we don't consider ordering cost. We don't order the stuff. Even though for manufacturing they still need to order the raw material, but it's not the decision we consider now. Plus, we have the setup cost. This means every time we run the machine, we have one setup cost, right? Cycle 1. And then we stop running the machine, wait for several days to begin to run it again, we have another setup cost. So, first look at setup cost, D over Q, right? Same thing. How many times we have to run a machine per year? This is the annual demand, right? D over Q, right? For example, your annual demand is 1,000. Every time you produce 100 units, so that means 1,000 divided by 100, you have to run the machine 10 times per year. And then this number times S, which is the one-time setup cost, is the setup cost for the whole year. Clear? For this setup cost, D over Q times S is very similar to the EOQ. But instead of ordering cost per time, now it's setup cost, setup machine equipment per time. Carrying cost, okay. I divided by 2 times H. We have explained that's the EOQ. Now it's IMAX, not just I, right? IMAX divided by 2 times H. When the EOQ model, anybody can explain why the holding cost for the EOQ model is Q divided by 2 times H? I have explained to you last Friday. Anybody still remember? Why is Q over 2 times H is your holding cost? For the EOQ, it's a review. Why is Q over 2 times H? Why is Q over 2? Okay? H is the holding cost per year, right? If you hold like one iPhone in your warehouse for 1 year, maybe you charge $100, right? Then what is Q over 2 mean? What does Q over 2 mean for the EOQ? Half. What does this point mean?
The average.
Average, right? Very good. Right? Q over 2 is the average inventory level for EOQ. We have discussed why it's average, because the strength decreasing line, right? It's not the curve line. So that's we know the average is exactly Q over 2. Half of days you have higher than Q over 2. Half of days you have lower than Q over 2. And then the rate is stable. So for the EOQ model, to estimate the holding cost is pretty straightforward. Q divided by 2 times H. Now EPQ, still H, holding cost per units per year. IMAX divided by 2. Now the first question I want to ask you guys, why we can't use Q divided by 2? We still have Q, right? We also have a QP here. Why we can't use QP divided by 2 times H to estimate the holding cost? What's the problem if we use that formula?
Production rate's higher than your demand.
QP divided by 2 times H. That's Charles' formula to estimate holding cost here. You know it's wrong, right? Why I'm wrong?
Because they're not the same. I mean, production And sales aren't equal, so you can't divide it, you can't come up with something in the middle.
You're selling some of the units that you're producing,
Right.
Uh-huh.
or you're not actually holding them. So after you produce
You
them,
sell.
you sell them.
Yes. Well, I think you guys get the points. Let me wrap together. You choose Joshua and Alan's answer is that the holding cost only relate to the inventory level. Holding cost has nothing to do with how many you produce. You can produce 10,000. If you sell all of them in one day, we don't have any holding cost, right? So it doesn't matter how many you produce. It really matter, okay, at the end of the day, we count. Well, anytime, I mean we count how many on-hand inventory we have. QP in this model is your production quantity. Well, when you produce on the same time, you also ship or sell to the customer. In the EOQ is different because when we order Q, that is, right, the highest inventory is Q, right, it's keep decreasing. But here, it takes us several times, several days, until we reach this maximum production level QP. And we know for sure when we reach this point, our inventory is not this point. It's much lower than this point because it takes us like 3 days, right, to this point. So inventory is Imax, which is much lower than your QP. That's the reason you should use the inventory level instead of the production level for the EPQ model. EOQ model, Q is equal to Imax. Clear? But when you order Q, right, that's your Imax, maximum inventory level. So that's the reason you can still use this notation. Imax divided by 2 for EOQ is no problem, but you understand. Imax for EOQ order quantity is the Q. Right? But here we cannot use Q. Right? It's different now. Okay, the next question is that why we can use the Imax divided by 2 times H to estimate. So basically speaking, why Imax divided by 2 is the average inventory level. Do you agree? Imax divided by 2 is your average inventory level for the whole year. Agree? Why?
The same reason as before, it's not the production level, it's the inventory level.
Yes, but Adam, my question is why is Imax divided by 2?
It's the average again.
It's average. Why is the average? I know it's pretty straightforward. Previous student tell me it's a triangle rule, something like that. When I say, right, this is a triangle, so half is the average for the first triangle, right? And the same, from Mx to 0, the average another is the same as Mx over 2. So we combine these two together, the average is Mx minus 2, divided by 2. Right? So it's similar, right? So now you understand, right? Why is Mx divided by 2 is the average inventory level, right? And times H. Okay. So this is formula. I hope everybody should write down this formula. TC is total cost. Imax divided by 2 times H plus Q, D over Q. I would write down QP times S. Okay, finally, we come to the Imax. Because the decision variable here is Q. Well, Imax is not a decision variable. Imax is in fact the function of Q. QP times P divided by P times P minus U. That's Imax. Well, P is the production rate. That means every day you produce like 100 units, right? U is the usage rate. You think about demand rate, such as every day your demand is 50, right? Then P minus U in our example is 100 minus 50. Okay. I will ask you guys to explain why this makes sense for us. Let's give a simple example, right? Let's say your QP is 300 units. Your P is 100 units per day. And the U demand rate is 15 units per day. Right. Okay. Then we can plug in the formula to see what is the maximum inventory level. So it's 300 divided by 100 times 100 minus 50, then we should get 100 units. If we plug in the formula, 100 units is our maximum inventory level. Okay. Just look at this simple example and then also refer to the picture, a graph. Now, a question for you guys. Why this formula can calculate the maximum inventory? This point, right? Why this formula give us the value of this point? I would suggest you decompose this formula into two parts. First part and the second part. Let's first look at the first part. QP divided by P. What does this mean? QP divided by P. QP is your production quantity.
Total, it's like your total divided by what you want to have as a maximum, divided by what you can make on a day.
Then what's the result?
You're holding what you're holding at that point. I mean, what you're gonna end up with your inventory? It's your inventory total, isn't it?
Not really. Not really. It's QP over P. Oh, sorry. QP over P. Right? You can see the example is 300. You are produce
300.
300, right? Divided by 100. That's your daily
What you do.
on trail.
Wait, how many days it would take to produce the
It's
quantity?
how many days your production lasts, right? Here is very simple, 3 days. Right? Okay, so this ratio gives us the timelines of your production. In this simple example, that means you produce 3 days. Times P minus U. What does P minus U mean? What does this represent? Production rates minus the demand rate?
That's how many units you have, like,
Yes.
in your inventory after that day.
Very good. So it's like the inventory rates, right? Every day, how many accumulated inventory you have? Here, 50 units, right? Because you produce 100, you sell 550. So every day, you accumulate 50 units. Now it makes sense for you guys, right? How many days? 3 days. Every day, we accumulate 50 units. So, my mistake. Just find that's it. 150. Nobody points out that. So it's 150 units, right? So 3 times 50, 150 units. That's at the end of the third day, you have the maximum inventory 150. Clear how we get that? It's the time of a production times the daily accumulate or weekly. It really depends on units of measurement. Accumulates inventory. The result is IMAX. It may take you some time to digest the IMAX calculation, but hopefully you get some sense now. But definitely you need to get familiar with this formula. Okay. Questions? Comments? Concern? Complaint?
EPQ though doesn't necessarily work for anything in production though. I guess my question is, if you're a season, say you produce artificial Christmas trees, you're not gonna just try to kind of keep up. You've got to produce a huge amount because the demand's gonna come all at once. Your demand is not.
Christmas tree, we can't use EPQ model because think about the assumption. Demand rates must be constant, right?
So you're not
But any product has seasonality or strong seasonality, we can't consider EPQ. That must be some other model. But what you can do, still can use EPQ if the seasonality, like for example 1 month, is pretty stable. Every day in this month, the demand is stable. Then we can shorten the time period from 1 year to 1 month. Well, for this 1 month, we think about is the flat rate, and then we can use EPQ just for the production plan for this month. But for the regular season or low season, definitely that's different story. So that's why, as I told you guys at the beginning, EOQ, EPQ model are not widely used in industry. It's too simple. Inventory management usually is more complex than this simple model. But you can see we already spent a lot of time on these simple models. Without understanding the simple model, how can we go to the useful complex model very soon? Very good. Any other questions? No questions? Everybody gets the formula? because we have to move on.
I do have one more question.
Sure.
On the formula, you have P minus U
Mm-hmm.
and 100 minus 50, but that doesn't equal 100 minus 50 doesn't equal 150. So where
Times 3. 300 divided by
so
100.
50 times. Okay.
Yes. That is 3 days, right?
Right.
Times every day you have 15 on-hand inventory. At the end of 3 days, 150 units. That's your maximum inventory.
3 times 50.
Yes. Okay. The rest. Okay, the formula is here. The same thing as EOQ model. How we get this formula, QP? You can think about, so this is a function, total cost is a function of Q. Because we can plug in the Mx into the first formula. Mx is a formula of QP2. We know P, we know U, we know D, we know Q, we know S, we know H, right? So when you plug Mx into this formula, the only variable is Q. We take the first derivative, set equal to 0, solve the equation, should get something like this. So QP is 2ds divided by h, which is the same as EOQ model. As we have a coefficient now, is p divided by p minus u square root. Okay. So it's guaranteeing us this is your optimal production quantity. Just follow this. It's optimal. Okay, if everybody gets the formula, now the rest of this class is this one. And I'm not sure whether the time is enough, I can tell you. Okay, a toy manufacturer uses 4,800 rubber wheels per year for its popular dump truck series. The firm makes its own wheels, which it can produce at a rate of 800 per day. First question, 48,000, what does this represent in our formula? 48,000, which notation corresponds to this one?
U.
D, right, the demand. 800 per day production, which notation corresponds to this 800?
EU?
No.
QP.
Which one?
QP?
P, production rate, right? So this 800 is the P. The toy trucks are assembled uniformly over the entire year, which means the demand is constant. We explained that, right? You know that we use EPQ this because this example, but if I give you as the exam, you should understand. Okay, that means the demand is constant. Then we can consider EPQ. Carrying cost or holding cost is $4 per wheel, which is H, right? Setup cost is $45 for production run, which is what?
S.
S, good, Riz. It operates 240 days per year. A question similar to our EOQ example. First, calculate the optimal run size. This is EPQ. Optimal run size, the same thing as economical production quantity. Right? What is the optimal production quantity? So just plug into the EPQ model, you get this optimal run size. And the next, minimal total annual cost for carrying and setup, right? Which means you have to calculate this one, total cost. But pay attention, you have to first calculate Mx after you solve the Q. Right? C, cycle time for the optimal run size, which means if you see this graph, that's a cycle, right? How many days for each run, each cycle? That's cycle time. The last question is about the runtime. Runtime, the first part. How many days you will run your machine and you stop, wait, and run it again? But the first part is the part 4. Okay, 20 minutes left. Let's you guys try to solve this problem. On Wednesday, there will be a faculty come to observe my teaching. So But we will also discuss inventory management. Don't feel nervous, I just let you guys know, right? You guys are fantastic students. I have nothing to worry about stats. Except maybe somebody give me a surprise, complain a lot on Wednesday. Probably not. But just let you guys know in advance, right? One faculty will come to observe my teaching, right? And also knows about you guys. So don't worry about that. So the pass A, optimal run size, just plug in the formula, right? EPQ formula. Oh, fine. Minus students.
How many units per day do you have left over?
Pause a little bit.
That's basically what you're.
290? 40? How do you get 240?
Not the days.
That's your leftover. That's your came in. 40 per day.
240 is the days, but U is the usage rate, which means how many units per day.
Usage, yeah, usage.
That's the difference.
Yeah, I was gonna ask about that when we did a 48,000 divided by 360.
No, 360. 240.
Okay.
Alright, good. Okay, some students already figure out that.
You'd
So
have to figure
for
that
the
out.
pass A, the only hard parts is to figure out the usage rates. All other parameters are given. D, S, H, P.
Divided by 200.
How to estimate the usage rates?
48,000 divided by 240 days.
Very good, Alan. So it's your annual demand, 48,000, divided by how many days you run this facility, 240 days. Then it will give us the daily demand or demand rates. Okay. 48,000 divided by 240. That's you.
So it's all that.
My suggestion, when you plug in the formula, I don't like the way the author writes down this formula, have two square roots. Because if you take the square root of the first one, it may give you a decimal number. Second square root give you another decimal number. Usually what I did, the same formula, but just one square root. So you first multiply these two together, right? Then take the square roots. The same thing, right? But in this example particularly, you will get the integer number. If you first multiply these two together, take the square roots. If you take the square roots separately and then multiply together, it give you a decimal number. It means very close to an integer number. 1,200? I think it's 600. Yes. Maybe you forget divide by 4, square root of 4.
Which one are you figuring out first? The IMAX, right?
Yeah,
I think it's gonna be
A first. QP.
So that's the 2 DSO rates times P.
Yeah.
2D. What is 2D? 2 times 48,000.
I think
That's what I
like the QP.
times 45 divided by 4.
Yeah, I'm just trying to figure out 800.
4,800.
48 why?
Because D equals the amount per year.
1,200?
Yeah, I don't think I did that right. Because I had put 200 in.
Yeah, that's 200, that's right.
Oh, that's right.
Yeah.
Oh, okay.
So part A?
Alright, yeah, I got that. Okay, so you got oh.
you, we just gonna do 48,000.
Okay. 200? EPQ. So it's just plug in the formula. I think it's 200.
Yes, it's pretty close.
You start plugging in the change. I haven't finished it yet.
What's on 200? Okay. That is correct. Still 1,200?
Start from the bottom one.
1,200?
I had it.
Okay. And that should be correct. Michael, you should double check. They have 1,200. You got 600.
800 minus 2.
I mean, that's QP. They got 1,200.
I haven't got that far.
You guys, that's two?
I haven't got that far.
Okay.
No, I'm working on it.
Have you guys find past A?
Yeah.
Was 48.
Yeah. Great. This is fast. You're slow. Just kidding.
I had to write it all down.
But you guess the idea very fast, right? Those close enough. I think that must be some calculation error. Should double check. It's close enough. Yes, great. Good. That's okay. Yeah, see, you're right.
48.
Okay. So medicine already catch past A. You should guess 1,200 units is your optimal production quantity, right? EPQ, your optimal run size. Then you can move to past B. So what is the formula I write down there? TC minimum, minimal total cost. First calculate Imax, then
Where do you come from?
TC minimum total cost.
There's what my formula ends up looking like. 2 times 48,000. Running to 800, which is P. Production is
U is 48,000 divided by 240 days. That's U is the U.
200. 800 plus 200.
That's 200. U is 48,000 divided by 240. You should get 200.
I just put that 900. I put that.
Yeah, you can move further. Please.
But you have to see.
Find the cycle time.
Think about cycle time. How you get that? Cycle time is the
1,200.
is the time, right? One cycle from your production PM.
And then divide that by.
How many days will be the production?
You're not
Think about it. I just saw. Yeah. How do you calculate the cycle time?
production per day.
I think it is. Some students have finished past B already.
For some reason, I was looking at one of them when I saw them.
Okay, you want to finish part B? Great.
No, that's 48.
I think about part C.
Oh, why not?
QP.
Why you guys like decimal number? That's the reason because QP I told you guys. First multiply them and then take the square roots. Otherwise you will get decimal number. Right? Because I don't like this formula. Why they have two square roots? You should always multiply first and then just take one square root. And you should get integer number.
Okay, part C. Anybody has finished part C? Part C.
On the other side, you just got 2 times 48,000 at the top of the numerator. You got the times about 45,000.
Yeah, because it was 800,
Hard. It's hard. Part C.
and then you subtract 200 from the kids. And then you multiply that by
I just put this straight in case they come up.
5 minutes should have been.
Still part B.
Third decimal place.
Question?
How you find just Q?
Yeah, you find Q. You want to find Q. Q is the part 1, part A.
It's the same as QP?
Yes.
Okay.
I would rather write down QP instead of Q because it's kind of confusing.
Yeah, I was just making sure that's the same.
Because my formula I write down QP.
Okay, I see. I got you.
And then cycle time for the not sizes.
Yours? D? What is a D? What is others? S is 45. S is setup cost.
QP is 1200, right? So
P
48,000
is 800.
divided by 1200.
Production. U?
So it's production.
No, U is not 1200. How do you get that?
8,000 is total rubber number of wheels divided by
No,
how many you gonna run
Yeah.
each time? 1200.
that's 200.
To get it.
Yeah. And then you plug them in, you get
40
1000.
runs a year.
That's 200.
Each
Right?
wheel.
Everything you get and then plug them in.
Well, I'm just acting a little bit different. I'm just looking at it.
The max.
So for being
Inventory.
all you did was took total number of wheels per year divided by how many you make in each run, right?
Okay,
Yeah.
How did you do it for?
let's do this. Let's do this together. Pass A. Most students have finished Pass A. Right?
Why use 9 for 9?
So Pass A is pretty straightforward. Anybody can tell me how to guess Pass A? Optimal run size? Any volunteer? Pass A? Q times what?
48,000.
48,000 times S. What is S?
45.
45 divided by 4 times 800 P minus U. How do you estimate U?
48,000 divided by 240.
48,000 your annual demand divided by 240 operation days. So you should get 200. What is the final result? 600?
1200.
I think most people guess 1200.
I mean, so yeah, 1200 minus 200 is 600.
Yes, yes. Okay, that's the pass A. It's pretty straightforward, right? For pass B, first we need to calculate the Imax. I think Rins has finished that. How do you calculate Imax?
It's 1200
500 QP you guys from pass A.
divided by 800
Uh-huh.
times 800 minus 200,
Yes. We guess equal to what?
900.
900 is your maximum inventory level. Then you plug in this 900 back to the formula to calculate the TC, right? So the TC is Imax divided by 2 times H plus D over QP times S. So it's 900 divided by 2 times 4, right? Plus 48,000 divided by 1,200 times 45. What is the final result? Total cost. What is the total cost?
3,600.
3,600. Very good. You can tell your manager that's the guaranteed minimal cost. Okay, part C. Many students stuck here. Cycle time. In fact, it's very straightforward. Once you understand. The cycle is here. From day 1, you begin the production until, I don't know, question mark date. You resume a production. So that's one cycle, right? It's very clear from the graph. But the problem is that, how many days in this example? This cycle.
2.
Anybody guess that? How many days? Part C? 6 days? How do you get that? Mike?
So you would,
You are right, in fact. You are definitely right. So use QP, right? How do you get 6? 6 is the correct number.
I did the 12,000 divided by 800.
Divided by 800? Should divide it by 200. So it should be QP divided by U. Then it's 6 days. Why? QP is the production quantity, right? That's in this cycle we produce totally 1,200 units, right? In this cycle, every day the demand is 200. When we resume our production, when we use all of our inventory, we resume, right? Then how many days we can last? It's the total production quantity divided by daily usage. That means after 6 days, our inventory level hits 0. We resume our production. Clear? QP divided by U, usage rate. Part D. Part D asks us about how long will you run the machine. Right? Runtime, how many days? So that means from the graph, this part, when do you stop the production? How many days?
One and a half.
1.5. Michael, you figure out again. Okay, you are right. Now this time you can tell us the formula, right, Mike?
That was the 1,200 divided by 800.
QP divided by P, right? So it's 1,200 divided by 800. You will get 1.5 days. It's pretty straightforward. You will produce 1,200 units. Every day you produce 800. That means you use 1.5 day to finish the production of 1,200 units. That's the runtime. Now we have answered all the questions the manager should concern, right? What is the optimal run size, and how long you should run, and how long you should wait to resume the production, and also what is the final cost if you follow our suggestion. Questions, comments? So we take some time to understand that, but hopefully this example can be very helpful for your homework, maybe exam. I'll see you guys on Wednesday. You guys? Vince? Alan? Yeah, right?